Short. So good evening, everyone. Thank you very much for coming to the Red Badger office. We have a sneaking suspicion this might be a popular event, so thanks very much, Evan, for coming to do your talk. I just want to say a few little words to say thank you to Amy and all the badgers who helped out today to set up this event as well, and a particular thank you to John sitting over there working, actually reaching out to Evan and getting the whole sort of process started. So one last little thing. So if you like what you see here and like these events and this kind of stuff, we're hiring. So please come and talk to us, find out some more about what we do, how we do it, and how we'd like to, try and get Elm into our projects of clients. So can you give us a shout? Yeah. Awesome. Yeah.
Okay, thanks. Okay. Okay, I'm Evan Czaplicki. I designed this programming language called Elm. I've been working on it for a couple of years now. So how many folks have Elm installed? Let's say. Okay. How many folks have? How am I so loud? Okay. How many folks have made like a decent sized project where they're like, yeah, I kind of know what I'm doing. Okay. How many folks are like, this Elm thing, weird? And how many folks are using React, like at work or something? Or okay. A map is forming. Okay. Okay, so I wanted to do a talk that sort of got at the sort of how Elm came to be and why it's interesting from the perspective of sort of what's going on in the JavaScript world. So over the course of working on Elm, we came to this thing called the Elm architecture, and it's not something that it's not something. What's happening?
It's just a bit of a delay.
Okay.
Sorry.
It's like, don't look at the man behind the curtain. So as we were making stuff, sort of this architecture emerged naturally. So I called Elm architecture not because like it was the secret plan all along, but because Elm made us realize that it was a nice thing. And it's been cool to start seeing it being influential for people who are doing React stuff. Okay, so when I think about the Elm architecture, there are a couple key pieces. So first is this foundation of functional HTML, not just you have the DOM and then you go mutate it and you do it in a functional way. So that's sort of the foundation of everything that comes after. Next is reactive programming. This was sort of what pushed my thesis work forward, but it's like less important than you'd think. And from that comes this emergent architecture. And then at the end, we'll talk about how to integrate with JS, maybe talk about some companies that are already using Elm. There are about 5, and then others that like don't tell me about it, but do it anyway. And so I sort of know what those stories are like and can share some of that. Okay, so for functional HTML, first I have some old graphs. These are old numbers, okay? This is like from a year ago. So it's small, but this was taking like Backbone, Ember, Angular, React, and Elm. And this was running the to-do MVC application through a bunch of activities. And if it's shorter, it's nicer. And so the interesting thing here is that React actually was doing really well compared to Ember and Angular, which were like the hot thing at the time. And then compared to that, Elm and Mercury, all of which are doing the same kind of tricks, are doing better again. So what I want to emphasize here is that when you're doing functional style HTML, you can get speed improvements if you're not being clever. And if you are being clever, like it can be quite good. Okay, so what does this mean? So when we talk about HTML and Elm, it's just sort of creating values that we can put on screen. So if I make a little Elm program, I can say import HTML exposing everything, and then main equals text hello. And I'm going to run this in Elm Reactor. So I can see hello. Fairly straightforward. So here, for folks who are unfamiliar, you can read this as like I'm applying the text function, but we don't have to put parens around everything. Okay, so text, that's kind of cool. Relatively straightforward. We also have this format for every tag that exists in Elm. So, or sorry, in HTML. So the setup of it is when I create a div, I'm going to have a list of attributes, a list of children, and then I'm going to get out an HTML chunk. And the same pattern is for all the tags. So scan is the same way, image is the same way, et cetera, et cetera, et cetera. So when we start playing around with that, we can just like make stuff happen. Very exciting, right? You can tell it's working. So if we say, okay, that's a nice building block, let's have more of it. Let's call that hello. And then I can say main equals div hello. I should look at my keyboard. Hello. Okay, more exciting. Okay. So this is like, this isn't exciting, but there's actually something surprisingly exciting here. So I don't know if you've ever tried this with like DOM nodes. You say, oh, I'll create a DOM node and then I'll use it 3 times. The DOM is just like, no, there's only one. And it'll take out the other 2 when you try to put it in. So this is kind of cool. And we can build up stuff like Yogi. I don't know if you guys have Yogi Bear here.
Yes, we do.
You do? Okay. Good for you. He's the bomb. So now I can put Yogi in here. Dun, dun, dun. I didn't import. Dun, dun, dun. It doesn't expose that because I messed it up. Someday. Okay, so we have Yogi Bear there hanging out. So what's kind of interesting about this is when I started out with Elm, this was kind of all I wanted to do. Not quite in this form, not with the DOM. My initial goal was I just was very frustrated with HTML. So I was interning at Google on the iGoogle team, the very successful. In 2004, it was. And I was doing backend stuff and finished that a bit early. So I ended up helping my friend with a front-end project. And so I was using JavaScript and HTML and CSS, and I was doing it at Google. So I felt like, how can I be having such a bad time when in theory, this should be like the best tooling out there. Maybe not the best, but like if it should probably be good. And I was having issues like, I want to center this logo, and the internet was just like, are you sure? Like it's easier if you don't. Another one that one was just like, that one made me really mad, but there was another one that just was like scary, which was I had a sidebar that appeared on all the different pages, and I was like, I'd like to reuse this sidebar on all the different pages, right? And it was just like, no, we don't do that. We don't do that. You can put it in an iframe, but like you shouldn't. And I just was like, what is happening here? So really the core was like, can we start to build up HTML in a functional way as opposed to going and tinkering with the DOM? So, okay. So this is kind of cool. But so how did we make it fast, right? So what's happening when we write that kind of, let's look at a little example. So imagine we're making Twitter and someone implemented like a top bar, and it showed like you have your Twitter thing and it has some information about the top. You can view that as some information about the side and the feed, and you can view all those things. So I'm taking a sidebar model and I'm turning it to HTML. Or I'm taking a top bar model and I'm turning it to HTML. And I put all that in a div. CSS is applied and it looks like Twitter. Now, because we're doing stuff in a functional way, we're actually sort of building up values. So when I say div of hello, 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 yogi, yogi, hello, it's actually building up that structure. And when there's an update, it's going to build it up again. And when there's an update, it's going to build it up again. So it starts looking pretty bad if you're building up that whole structure every time. So there's a trick. This trick is called lazy. So in all these cases, we have a function and we have a value, and it produces HTML. So what lazy is saying is, give me a function, give me a value, and then I'll say that I have HTML, but in fact, what I'll have is just the function and the value lying around, ready to go. Now, when I actually go to render it, I can say, has this value changed since the last frame? If not, I don't have to do, wait, has this changed since the last frame? Yeah, if it hasn't changed, then you don't have to do any work. You don't actually have to build the structure and see what it looks like because you know what it is already. So this actually lets you save a ton of work. So when you want to optimize your rendering, your code ends up looking like this. So you just put lazy in front of do this thing, do that thing. And so suddenly, this is how you're getting that big speed up you saw on the performance charts before. And I added visual cues to show the relative speed of these two things. I think it's like not to scale. Really. Like this is just like a much better bicycle. Or yeah, whatever, you get it. So yeah, so I wrote a bit about that at that place. So this is kind of the key trick we're doing. And this is something you can get access to in React. If you do should component update, do people use that thing? So yeah, so like sometimes you're like, okay, I'm gonna try to be clever here and do some optimization. And what's interesting in Elm is like, due to sort of language design, we can get that for free, where you don't have to be really careful. Is there a local state that also should treat, and you're trying to be like, and then someone's going to add a feature and don't realize that should component updates in there, and then it's like not, and you're going to be like, yeah, if I click this button, it's nicer if it just sort of is baked into the rendering. Okay, so that's kind of the foundation of rendering. And when I was making Elm, I got to a point where thing roughly like this. In reality, it was Yogi Bear and then like a pentagon and then like a tongue twister. So like I got to a certain point and I was like, this is cool. Like I can make a functional picture, but can I make that picture move? And so that's how I got into reactive programming stuff. So the concept here is that like I'm sitting at a computer and like something is sending me pictures to show on screen, and then I'm sending it like stuff, like interactions, events, whatever. So reactive programming is kind of all what happens in the middle. So an Elm program is just going to be filling this space and sort of processing these events in an interesting way. And so I called these things signal graphs. Now I want to get into these so that we can then not have to use them anymore. So we can like find a pattern and be like, oh, I'm glad we know the plumbing. So a signal graph starts with an input. So this is something like in Elm mouse dot position. So I don't know if everyone's familiar with reading types, but when you see a colon like this, you say like has type. So the value mouse position has type signal of integer pair. And if it was just an integer pair, that'd be something like 3, 4, right? Not very exciting. This is a signal of integer pair, which means it's an integer pair that's like changing as things go along. So let's look at that. Let's say, in addition to having an image source, I'm going to set some styles on Yogi. Style. Width. So now I can say Yogi 400. and hopefully that will work. Yeah, okay, good. Yogi 40. Okay, and it'd be bad if interactivity worked by the programmer going and manually changing the values. So what you can do in Elm is we have this thing. So I mentioned mouse position. Import mouse. Where's my mouse? That's funny. Okay, so I can say signal dot map yogi onto, let's do X. So when I look at this, I can, yeah, I love this because it's like he's like a little bit, you know? But okay, so what's happening here is mouse X isn't just X right now. It's, well, when you evaluate this code, it doesn't evaluate to X on this particular frame. The meaning of this is X right now, and however it changed will flow through everything else. So this was kind of the core idea, where one day I just was like, instead of mutating values, what if the values like changed everything else? And briefly, I thought I invented this, and then I found out there was a lot of prior work, and I was like 14 years late. And then later, like many years later, I found out that they were like quite a bit late. I don't know. So the key idea though was like, what if the values just updated everything naturally? So yeah, so another example of a signal is keyboard presses, where like as things press, like you sort of get those things flowing through. So next we have transforming things. So map, we actually just saw this. You give it a function from A to B and a signal of A, and it produces a signal of B. So just apply this transformation. So when we look at this yogi, when we see the code of it, I'm saying, okay, map the yogi function onto mouse X. And we can go crazier too. Dun, dun, dun. So yeah, Elm has, I guess in JavaScript it's called destructuring assignment. So we can just say, oh, it's a pair of things. Let's see. Thank you. But the compiler would have caught it. Okay. Okay, so next, yeah, so as a little example of this, if we had an is consonant function and we mapped it over key presses, we get like space isn't a consonant, control is not, et cetera, et cetera, et cetera. Okay. So yeah, okay, yeah. When it comes to like what we have so far, it's cool, but like it doesn't remember anything, right? So like imagine a form that you could like poke and it would like move. And then like you type something in and then it just forget everything that happened before. So we need some way to think about state. And so in Elm, that's called foldP. And so there was a time when I thought this was like a really funny, good name. And I don't know if I don't know if I feel that way anymore. So if you're used to using languages like Elm, there's things called fold L and fold R, like fold from the left, fold from the right. So this one is fold from the past. And I was like, ha, it's a pun. Since then, though, I don't know, puns are like fun at first. You know what I mean? And maybe I would give this a different name, like state, or like. In any case, the point of this thing. Let's see if there's. Yeah. Okay. Okay. Yeah. So what's happening here is we're going to take a signal of A values, and we're going to have like an accumulator, the current state. And this is a function that's going to be saying, take whatever comes in, take the current state, and give me a new state. So it's essentially you have an update function that lets you step your state forward. So in this case, we have state of 0, and our update function is going to take whatever the key is, take the current count, and then just increment the count. Forget about what the key was in particular. So as we run this, our count will increase when we press stuff. Should we do an example of that? Yeah, okay, okay. All right. Let's go back to just width and comment that line out. And then I'm going to say width is equal to signal.foldP click count plus 1 0 mouse.clicks. So based on the mouse clicks, which when we click a thing will happen, we're going to update our state. Anytime we do, we're going to say, okay, I got to click in. I don't care about that. And I have to count, and I'm going to update that to a new thing. So now width is this thing that's changing over time, and I can pass that into Yogi. And it's going to be too small. That was the thing. That was the thing. Or I would have to click a lot. So yeah, so now we're remembering things. Cool. Okay. And there's one last thing to do, which is merging signals. So in Elm, we have a basic one, which is you take two things and then you make them into one thing. And we have a fancier one, which is these signals are, you put them together with a function. So this would let us write things like, let's see. So if Yogi took a width and a height as separate arguments, I could say signal.map to width and mouse.x. Okay, so the width should be based on clicks, and the height should be based on the x position of the, oh, that is confusing. Okay, height will make it based on the y. Okay. Will it work? Okay, so what this means now is if you have multiple signals going around, we can feed them all into something. So this was this was kind of what my thesis was all about, the original work on Elm, and it's pretty cool. It's pretty cool, but an interesting thing happened over time. So as we started making more and more programs, one thing that's interesting is the first thing that was easy to do in Elm was games, which like wasn't my goal at all. Like I wanted to make, like the root problem I had was like I want to make a website and it won't let me, you know. And then I ended up with like I think like this was the key example that I had set up. And I was like, I like this. This makes me happy, but it's not a website. You know what I mean? If I need someone's contact information, I'm still stuck. So what ended up happening as we started making more and more stuff and started to figure out how to do forms and all these kinds of things is a pattern started to emerge that we just saw in every Elm program. So when I think of Elm, I think of it as like this box, and there are little ports coming in and ports going out. And so okay, more context. So yeah, it's hooking up like before, and maybe it's hooking up to the internet as well. But essentially, like we start to notice a pattern in Elm world where the signals hooking up the incoming values to the outgoing values always have the same shape. And it's kind of this shape, like you take all the inputs, you give them to a big thing, and then you like, one of them goes and you render it, and one of them maybe does some HTTP stuff. So once we started to see this pattern, I actually was at a lunch meeting where a friend of mine was showing Elm. And the part we stumbled over was the signal stuff. Like, it's kind of cool, but people are like, I don't really know what you're talking about. I'm not sure if that's how it went here as well. So on the walk back, I was like, I bet I can make a library such that no one ever has to think about signals again. And so like we're standing outside my office and I'm like, I bet before you get back to your office, I can write the library and share it with you. So I did that, and it's called Start App. So when you're actually messing with Elm as a beginner, you're not going to see signals anywhere. So this is a little example, the counter example. There's no intentional pun there, but I don't, what do you call it? So I just have a little counter that's counting up and down. And so when we look at the Elm program that's producing this, essentially what we figured out is that an Elm program always breaks up into 3 parts. First is the model of what's happening. Second is a view. So take the model as a parameter and what should it look like. And finally, an update function. So I take in the model and I update it in some way. So Start App is kind of just like doing all the wiring with signals that we were talking about, except you don't have to know about it. You just say, hey, start here, show pictures. This is kind of interesting because we can pretty easily start adding stuff. So let's say I wanted to add to this another button that said reset. Now, okay, there it is. Now, what's going to happen when I press this? Does anyone know? Yeah, so I just copy pasted. I didn't actually add a new feature. So in Elm, we have this concept of an action, which you can read this like enum in Java, or yeah, let's go with that. I'm creating an action, and there are 3 different variations of it. So when I have my update function, I need to handle the new case, and reset will go to 0. So, yay. Okay, so what's kind of cool here is that the connection between the view and the update all goes through this action type, not through interspersing of code, right? So I just say whenever a click happens, the data that's interesting to me is decrement. So if we, if I say debug.watch action, let's see if I can show this to you. Okay, so if I go and check out main in debug mode, so I added a watch, which will tell you things about the current frame. This is the time traveling debugger, so we can sort of just go back through everything that's happened before. And so for those of you who have seen this in Redux, we were first. But yeah, so you can start to see like, okay, these actions are flowing through, and I can actually look at them. So one thing that comes from this is when you start wanting to test your business logic, you can just have a list of these things, these actions, and say, okay, if I run this list of 10 things, my model should be in the state afterwards. And you don't have to mock in a UI. You don't have to set up a server. You just say, these 10 things happened. No Red Ink in San Francisco, they're using quite a lot of Elm these days. They have maybe 4 or 5 people writing it most of the time. That's my understanding. And so this has given them some good mileage, right? Essentially, all business logic is just like a function that you can test as opposed to mock a stream. It's just very straightforward. Okay, so we added a feature. That was pretty straightforward. So let's look at the like real version of this. So this is the same code, but I kind of made it more legit. So I added type annotations to things, but the same stuff is kind of going on. And instead of having just saying the model is equal to 0, I actually define a model type and let the stuff flow through my program. Let the types flow through, yeah. Okay, so if we take a look at this guy, yeah, it's gonna look the same. This is not an exciting demo. I apologize. Dun, dun, dun. Oh no! I copy pasted too much. Okay, so I just changed the styling. But the thing I wanted to show here more was that as you start to get a bit fancier, you have these affordances that help you out. So type signatures, for example, are going to say to anyone using your code, here's actually what's happening. What's cool about Elm is that all types are inferred statically, and our compiler is really, really fast. So like if I'm not sure if this will work. Let's see. So like that was all the core libraries, and my project is actually just the counter. So when I mess with this, if I say instead of incrementing it's gonna do +10 instead because I'm a maniac. Like that's the kind of compile time we're talking about. And when we've been refreshing things in the browser, like it's been, oh, I stopped it. When we've been refreshing things in the browser, it's calling the compiler behind the scenes. So we have something that's very snappy, and it's going to be able to find figure out all the types in your program. Now, I like languages with types, but I don't think of myself as like a types person. Like it's useful to me, but it's not like I don't feel like I have to be a missionary about them, because if you do it right, they're just useful. Right? And like if something is good, then it doesn't have to like. There are folks who will present it as like, here's this thing, and I need you to believe that it's good. And I feel like if you have to believe it, that's weird. When you see it, you're just like, oh, I like that. I wonder if I can show some examples of that. No, okay, no. So I have a version of the compiler that's coming out next week, and the error messages are already nice, but I'm very excited for the ones that are coming out next week. Maybe at the end, if we have time, I'll show some of that. Okay, so the point of showing all this kind of stuff is to say, all right, that's cool, we made a counter. What happens when we want 2 of them? So imagine a world where, oops. We want the same counter code we just wrote. Oh, it's compiling. It's downloading. It's compiling. I apologize. Okay. So we want to use those counters that we had before, but now we want 2 of them. So this example isn't particularly beautiful or exciting, but it's the core form of I made a story for this newsfeed type thing, and now I want 2 of them, right? So it's the basic unit of how do we start making these into components and putting them together. So what's interesting in Elm is that when you start putting these things together, let me close some stuff. Okay, so the counter pair has two key parts. First is a counter, second is a counter pair. So what it means to be a counter, all this code is going to look the same. You can initialize it with a number. You can update it, it increments or decrements. You can view it, it's got a div, it's got some buttons, it's got some text. Same as before. And in Elm, we have this module system that lets you say, I'd like to export only these things. So we can actually hide a lot of these details. So to the outside world, they can know that action exists, but not what any of the particulars are. So an outsider will just know, I have the ability to update a model if I have an action. That's kind of all they know on the outside. So when I want to make a counter pair, I can just import counter, and I have these things available to me. So when I say, what does it mean to be a pair of counters? Well, it means to be like the essence of a counter twice. And when I initialize a pair of counters, what I do, I initialize two counters. The part where it gets a little bit more interesting is when we start doing updates. So a counter action is something that is known by the counter, but not by us. We just know that it has a name and there might be stuff there. So essentially what we're doing here is, oh, I have to stretch the enum analogy. So normally in an enum, you just have like names of things, and now you're actually able to associate data with those tags. So you can think of it as like there's a reset tag, no information associated. There's a top tag, and it has stuff alongside. So essentially we can say, I can get actions for the top guy, I can get actions for the bottom guy. And when I want to do those updates, I just call counter.update. When I want to view things, I just call the subview. And I'm going to gloss over some details for now. So what this means is, you know, I'm Tom in division A, and I'm working on the news feed. And then now I'm Bill. I should have physically separated them, but now I'm Bill in division Z, and I'm working on the individual things. So now I can start to make my model of things fancier. So let's say we get tired of counter, user engagement isn't high enough, people are losing interest quickly. So we want to add some new features, and we'll tell the marketing team about it. They're all on board. The feature we want to track the highest number we've ever gotten to, and we think the users will think of that like a high score, and they'll like it. So we can say my model is. I'm not sure if this is a good idea to do this again, but we're doing it. So instead of just having a model that's an integer, we'll have a model that's a record. High score is also an integer. So in Elm, we call these things records. It's very much like an object, but it doesn't have this, and it doesn't have mutation. That's the main difference. There's also the difference that I put my commas at the beginning. Sometimes people really dislike that, but yeah, but this is better. But this is better. No, I try to look at it like a, you know, when you have a bulleted like a bullet in a list. So when you have a bunch of them, it sort of indicates I'm starting a new thing. Once you get used to it, it's quite nice. You never forget a comma because you're like, ah, like how could you forget them if you put them all different like that? Right. It looks ridiculous. Okay, so when I initialize things, I give it an initial count. And my high score is also the current count. So when I create an alias for a record, I get a record constructor, so I can make more of them. Okay, and when I increment things, I'm going to say my count is now equal to, and my high score is going to be equal to the max of model.highscore and model.count plus 1. And I'm duplicating code, so I'm going to stop doing that. Okay, okay. And when I decrement things, I'm just going to say for simplicity, I'm not showing some features that can make this a little bit more concise. Okay, so will this work? Almost, almost. So model, I actually just want to show the count here, and then I want to add one for the high score. See. Cool. So now I have a high score tracker. Cool. Yeah, okay, cool. So the interesting thing here is counter pair didn't change at all. So we're actually able to be modular in a really nice way. None of that information leaks out. None of the event handling of things becomes talky between them. So yeah, so that's kind of the core pattern that's used and is like the essence of the Elm architecture.
Can I ask you a quick question about
Sure.
the main source code?
Sure. Well,
If you call it up, main.
yeah,
Oh, no, hang on. Counter pair, sorry.
yeah.
Why is top act and bottom act there to swap the arguments around? I couldn't read that.
So
Oh, sorry. Yes, because
yeah, I didn't want to show record update syntax, so I just was, you can use the record constructor and then give it the updated version of a thing and the old version of the other. There's a record update syntax, so you can just update one subpiece of everything, but I'm making it slightly nicer on like Monday or Tuesday. So I was like, maybe this is the way to go today. Okay, so the last piece of this is integrating this with JavaScript. So like, it's really nice when I get to write code like this. So we had the time traveling debugger done kind of mostly in JavaScript just because it needed some of those features. And it would work, and then I'd be like, yeah, cool. And then I like go to do something else, and I come back to it, and I'd be like, what have I done? Like, why, what does any of this mean? So, and it's like, it's doing time travel. So like, on some level, like, what did I think was gonna happen? But like, I don't know, it felt weirder than that. So we had an intern this summer who actually rewrote a lot of it in Elm, and just like, bugs were resolved in a way where just like you weren't able to write it in a way where you hated yourself later, which I think that's like a key feature for me. In any case, I'll have this experience again and again where I'll start writing something and I'll be like, this is good. But at some point you need to start integrating with JavaScript. So if you're at all interested in using this in an existing project of any sort, like the plan of, well, what if we just rewrote it is like the worst plan. Not because, it's a bad plan. So let's imagine a scenario where we have a search bar, and then we have like information that comes from that, and then we have like some side panel where we can filter the search results. So we can say, I only want things that are within this date range, or like, whatever, some sort of filter. And let's say I want just that piece to be an Elm. So like I was saying before, I think about Elm as this box where there are these incoming ports and these outgoing ports. So when you want to integrate with JavaScript, the way it works is essentially you send messages to these incoming ports, and it's going to send messages out through outgoing ports. So you can have these little islands of Elm in whatever your JavaScript application happens to be. So for the no-red ink people, they've done this. Essentially was their technique. Richard, their lead engineer, has this talk called "Growing the Oasis," where the oasis is defined as this part, and how can you. And they use tricks like. In the very first thing they did, they actually kept all the UI in React and just did the business logic in Elm because it was particularly hairy and they wanted to have the benefits of a type checker, and immutability. So in a subsequent project, they actually did the UI too, like converting from React stuff to Elm stuff is relatively mechanical. Like I think they wrote a Vim like regex replacer that did it for them. So relatively straightforward. And sometimes people say to them, how do designers, how do they do it, right? When they're looking at, what was it, Scratch, right? And what they've observed is like, it's close and it's basically HTML that looks a little different. And like, it's not like HTML looked great in the first place. Right? So like from a designer's perspective, they're just like, oh, it's the same, but like, instead of they're square. It's kind of the situation. So we haven't seen that be like a big issue in practice. But yeah, so that's a broad overview of the Elm architecture. Yeah, thank you. So are there any questions or anything? Yeah.
So it says on there, easy to test as well. So how do you go about testing your Elm code?
Sure. So okay. So the no-writing people use both the unit testing library and what's called like Elm check, which is property-based testing, which I really don't like that it's called property-based testing. I wish it was called fuzz testing or randomized testing, like something that said what it does. So essentially they're able to say, given this, I want these two things to be equal for random inputs of this certain type, and it'll just generate a bunch of crazy stuff. And when it finds something that doesn't work, it'll try to turn that into a minimal example. So it'll spit out, hey, this, and this, like, don't work. And typically you'll find weird corner cases, like if you have 0 and an empty string and an empty list, and then a list with only an empty string in it, like that input in particular, like something goes wrong. So that's the kind of testing they do. I think it's important to note, though, that there's a big like swath of things that normally you would test in something like Ruby or Python that you kind of get for free in Elm in a way that's relatively freaky at first, and even many years in. So you'll probably hear people say, like, if it compiles, it works. It's weirdly true. So like I work on a compiler most of the time, and I'll be like, you know what? I want to change like how type inference works, and I'll just be like, and I'll be like, hey, this doesn't match. If data ever flows in this way, it's gonna go wrong. And I say, okay, I'll fix that. And when I'm finally done, it's like, oh, type inference still works. That's it's like part of me is like, that shouldn't happen. You know what I mean?
Is it written in Haskell or compiler?
Yes. Yeah.
Which is quite similar, I guess.
Yeah. So they both come from like the ML family of languages. So there's like going back to 1973-ish is the general approach, and then there are a bunch of languages that grew out of that. So, and hopefully, yeah.
What would you say the main reason for switching away from something like Redux would be to Elm?
So I think the way the no-writing people would put it is like, it's cool to have good architecture, but it's also cool to have good code. And that's like the like aggressive, jerky kind of version of it. But well, and the reason I also say that is because when they were actually transitioning, the first thing they did was jQuery to React and then React to Elm. So I think you're actually getting quite a different thing when you're switching languages. So when you have immutability and a type system, it's just like freaky how easy it is to refactor stuff. So they'll tell me about situations where they have a large form that they're dealing with, and they say, you know what, we're modeling this wrong. Let me just change this thing. And that's used in like 5 different files. If they had been coding in JavaScript, they probably just would have looked at each other and be like, it's fine. it's fine. Let's just leave it. Let's not open this can of worms. And what ends up happening is when you make that change, the compiler is going to say, hey, you need to change this, this, and this, and everything will be fine. So I kind of do want to show the nice error messages that we have these days. Oh, it's live streamed. All right, well, it's coming out on Monday. Like, don't freak out. Okay, so I downgraded my compiler to do this. So I'm going to just show on the internet a bit of them. So this is an example that, that Richard pointed out to me. So he ran into this code. They have like a big old type alias of a person and all this information about them. And they wanted to get their full name out. So turn a person into a string, first name, space, last name. And for some reason it was going wrong and he was getting an error message that wasn't helpful to him. So in the new release of things, if you can see this, oh. We're doing quite a few things here. So first we say, here's the region of the code precisely where things went wrong. And we do like a vertical squiggly underline. And okay, get full name is expecting the argument to be blah. And what we do here is like a type diff. So it actually shows you exactly the fields that are different. And I added a little thing that's like typo detection. So if it'll look at all the fields and say, oh, these are like one away in, what's the distance?
Honey distance.
Liechtenstein?
Yeah. Yeah. They're like the distance between two strings. So if they're close enough, you can say, okay, hey, there's something here. And so Richard ended up like looking at this for a long time until he realized that like the N and the E were switched. And now we can just say, hey, like, look at these two things, something's different. So yeah, and so we're adding in a bunch of things like this. So another one that's kind of fun is, oh yeah, we have some beginner hints now. So like in Elm, when you append strings, you don't use plus, you use double plus. So there's like 100% guarantee that you're going to run into that as a beginner. I realize that, I apologize. Like there are reasons, but what we can do is whenever the compiler sees a plus and a string, it's going to be like, I bet I know what's going on here. And it'll say to you, to append strings, no, use the plus, and it links you to the docs. So we really want to give you this experience where it's not like I'm working with the compiler and the experience is like, hey, check out this code. And the compiler's like, and you're like, okay, how about this code? And it's like, and then you're like, okay, how about this code? And it's like, what? Oh yeah. And eventually it'll be like, no, right? Like depending on how fast it is. And eventually it'll say yes. So I want it to be more of like a collaborative experience where you have this tool that's just able to say to you like, hey, like here's a little thing that was going to cause a bug, and now you don't have to deal with that.
Do you have plans to change Elm syntax to be more familiar for JavaScript developers?
No, I've seen languages do that. At some point I saw a language that was coming out of the OCaml tradition, so same ML family of things. And at some point they were like, we're gonna just switch to a C-like syntax and it will be comfortable for everyone. And like, I think that's missing the point of the root approach here, right? Like we could change the syntax, but essentially it would make this programming model feel worse, right? So like I am making the wager that enough people will be like, get over the syntax and see the programming model and think that's nice. And for those people, I want them to have the ideal experience, not the like compromise experience. And so at the same time, accessibility is really, really important to me. So that's one case where I think we can be accessible in other ways because it's not as huge a trade-off. Does that kind of clarify? Like another reason we wouldn't do it is that like the curly brace stuff is kind of designed for mixing expressions and statements, and we just like don't have statements, right? Like it just doesn't make sense for the language to look that way in many ways. So.
Could you give a few advantages of using the Elm architecture where you have like one big model for your whole application compared to sort of component-based architecture that you might have with Angular?
So you say those like they're two different things, which I don't agree with. So I think the idea of the one big chunk of state is freaky to people, but think about it this way. So let's say I'm using JavaScript and just like going wild. My model exists somewhere in the heap, right? Each of these components is going to create something somewhere. Now, all that's happening in Elm is we're saying, instead of having that scattered throughout and no one can look at the code and actually know it, let's put it in a hierarchical structure. So fundamentally, it's the same thing, except ours has hierarchy that matches with your code, and the other ones don't, in my opinion. So does that kind of...
Do you find there's a significant advantage to thinking about an application in that way, in terms of side effects and code changing where you may not expect it to?
I can speak to how it feels when I'm sort of writing something from scratch or updating something. So essentially, whenever I start on something, the first question I ask myself is like, what does it mean to be this thing, right? Like, what is the model? And from that, sort of everything flows out. And so when I want to make a change to a component, I say like, what would it mean for this change to, like, what's the minimal representation of that? And everything flows from that. And I actually find that extremely useful, also because you have the model of your component in one place. And it's really easy to start to see like redundancies in that. So like if you have a list of, one thing that I didn't emphasize in this talk is the union type thing, the thing that was like enums. When you start to see like, okay, I have a Boolean, and if it's true, then there's a list, and that, all right, so like if I have a list of things and I can hide it, the JavaScript way might be to say I have a Boolean, and if it's true, then I have a list, and the list is definitely not null when that's true, but if it is false, then it should be null again. Like you can just model that as it's either closed or it's not, and it has stuff in it. So you can start to have a more precise idea of what's happening in your application. I don't know if that's...
Would it be fair to say things like the time problem debugger would be a lot harder to implement without the idea of a single state at home as well? Because like one of the things I saw with Redux, which I thought was quite impressive, was someone had made a blog and you could press a keyboard shortcut and it would dump the whole state into a string which you could copy, and he was like, you know, imagine for debugging, you could, when there's an error, you could just capture the whole application state and send it back, and then you could essentially recreate a session.
Yeah, so it's not in this upcoming release, but we're thinking of doing this kind of thing for the time traveling debugger, where you can I'm going to try to answer the question in a way that leaves that as a surprise. So it is true that the programming model of Elm, the fact that things are immutable, and that particularly that things are, side effects are controlled in a nice way, makes that stuff extremely easy. So it actually is possible in Elm to have multiple state holders. The key thing is that you're not arbitrarily sending off HTTP requests. So when I render something, like that isn't triggering stuff. And so it's safe for me to skip that and still be able to reproduce the same program. So I think in a lot of the JavaScript ones, the rules are kind of like, if you are good, things will continue to work. Whereas in Elm, it's like, it's built into the system that these things will work out, even if no matter how crazy you go.
So basically, you said that we can use M as a component of JavaScript big project.
Mm-hmm.
So can we kind of use the JavaScript modules inside M?
So that's trickier, but I think a decent number of the companies using Elm do something like that. So the way it would end up working is you'd create the trick for now is you create a div in Elm with a certain ID, and you have some helper code in JavaScript that like puts stuff in that, which is like hacky. And one of the observations I've made for the companies that have successfully started using Elm is they'll say to themselves, I'm willing to make one kind of weird hack for the benefits that I'm getting. So there still are these kinds of edges here and there where it's like, there could be a language feature for this or something, but usually like there's a little hack to mess around with it. Especially with JavaScript, there's always a hack to.
What are your future plans for something like server-side rendering?
So the next big thing I want to tackle in terms of language stuff is making it easier to bind to web platform stuff. So right now we have a package repo of stuff, and there's all sorts of people doing things. And one restriction this has is that you can't bring in arbitrary native code. And part of the reason I did that was there's enough of like a culture clash between like typed immutable yada, 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 and JavaScript that I didn't want just to get a flood of people being like, hey, I did all this stuff. And like, yeah, it breaks the rules, but like, I'm doing what I want to do. I want people to do what they want to do and also the rules to be respected. So in the next release, or sorry, the next thing I want to work on will be how can we give the whole community the ability to bind to WebSockets and like whatever weird stuff is coming out from Mozilla that's not standard, you know, in a way that just the whole community can participate in. And as part of that effort, there's like 10 lines of JavaScript that will make things work nicely on Node. And right now, like for Elm REPL, we just add them manually. So like, that's all running in Node. So it's possible. You just need a little bit of like poking right now. So it's also a goal to make that go away. So with the ability to bind to web platform and with the ability to run on Node directly from Elm Make, that kind of stuff will start to be possible. So.
Can you talk about the round trip to a server?
What in particular?
So if you're making a web request to a server and getting, say, JSON back, you had like the interaction with, I guess, a signal going out, a signal coming back in.
Yeah, so for the sake of this talk, I didn't get too much into that stuff. We have a library called Elm Effects, which is for this particular thing. And it lets you build up components like we did with the counter pair, except you also can thread through these kinds of requests. So if we look at this one, okay, so this is a program that is doing that kind of stuff. And it's set up just like the counter example, except it's threading that stuff through. I don't super want to get into the details of it, but I'll just say, like, if you look at the Elm architecture tutorial, examples 5 through 8, and Elm effects, that's all about this kind of stuff. And what's cool about this is if we go to the next one of these, it's the counter pair equivalent. And the pair part is roughly the same stuff. Hey, that wasn't. So yeah, and then we get crazy. Oh yeah, I should just, okay, 2 more of these. That's not JC. Trees. Oh, that's a great one. But yeah, so, and the point of these examples is to show like the code that is used for the component, you just put it into different contexts and it keeps working. So the last one of these is for animation, which goes through the same method of things. So this is the counter pair of rotating squares. So yeah, so all that stuff can be threaded through in the Elm architecture with a addition that I didn't want to throw at everyone. I did a like 3.5-hour tutorial last week, and I was like, all right, let's do that part. And that was the part of the tutorial where people are like, I'll look at this later again. So
I'm trying to wrap existing JavaScript libraries in Elm, and I don't know what the rules are. But
so
are you going to write them down somewhere?
Yeah, so it is a choice by me that you don't know the rules, specifically because like it's possible to wrap things up right now, but like I don't want you to yet. Essentially because there's not language support for doing that in a nice way. So I specifically avoided writing down here is exactly how it works. First, because that API is subject to change, and two, because I didn't want, it's like an obvious thing to do, right? Like I want to wrap this stuff up. And so I knew that if I added it, everyone would write these things. And then we'd have, when I did make language support, there'd be a big migration period and the code would break, and it's JavaScript. So it'd just be like, oh, it's broken now, I guess. So essentially the trade I made was like, I'm willing to grow slower to get it right when we add it as a language feature. So
when will that be?
So the stuff I was talking about making bindings to web platform, that's that stuff. So yeah, this is something that like everyone wants this. So like I've heard the message, and I'm like, all right, I'm working on it. All right. Cool. Well, thank you for listening. Thanks for all the questions. Hopefully that was helpful to you as well. Yeah, thanks.
Thanks, Evan. That was brilliant. So that's the end of tonight's meetup. The next one, I believe, is in January. We also do the React meetup, and that's next week. But there's need to rush home if you want to hang out. There's still some beer and wine and sushi, I believe. So it's going crazy, yeah. Thanks for coming.
Thank you.